Hello everybody, my name is Justin Clark, and for my project I looked into assessing indicators of dynamic stability in quadruped robots. The main goal of the project was to isolate indicators of locomotive stability through the comparison and analysis of 4 unique robots. Variables of interest during experimentation included the physical position of legs, the range of motion related to joint movement, the position of the central body unit, and the addition of leg stabilizers. These variables were assessed over 3 independent experiments. The internal design of robots was held constant over different experiments with respect to the number of sensors and initialization of joint parameters. Fitness was calculated by final displacement along the positive y-axis subtracted by a stability constant alpha. Alpha represented the proportion of time steps where the simulated robot demonstrated instability based off the position of its central body unit. Experiment 1 analyzed the initial performance of the 4 robots over the course of 50 generations. This experiment demonstrated basic locomotive ability of robots. Experiment 2 used the results in Experiment 1 to produce stronger candidates through a change in controller design that added proprioceptive sensors to the joints connected to the central body unit. Finally, Experiment 3 took the best candidate from Experiment 2 and analyzed changes to design and their effect on the displacement stability trade-off. The results of Experiment 1 demonstrate the ability of robots with strong leg position to the desired direction, the opportunity for motion of the leg. The SpiderBot and large BugBot were able to best perform due to greater possibility for displacement with corresponding fitness levels much higher than the other 2 robots. Experiment 2 showed the importance of regularizing the leg movement in terms of isolating direction. Robots with input neurons corresponding to joint angle vastly improved with the performance of robots during evolution. This is visualized in the shown plots, with the best individual BugBot having a fitness far greater than those found in Experiment 1. Finally, the results of Experiment 3 demonstrated the trade-off between displacement and stability of the range of motion of leg size. Robots with a smaller range of motion in actuated joints or smaller leg size demonstrated an increase in stability while forgoing displacement. This behavior seems to occur due to discussed trade-off. Robots with smaller range of motion or legs must maintain a more consistent movement, while robots with larger range of motion take advantage of smaller movements. I found it difficult to make notable changes to robot morphology that produced positive changes in robot behavior. Additionally, further possible work related to this project includes the addition of an evolutionary algorithm to evolve robot morphology over the course of multiple generations.